Okay, yeah, thanks for having me here today. Good morning, everyone. Today I'm going to talk to you about sort of just a bit of work that we've been doing over the last couple of years at Shawanaga. It's been a couple of years now. I think this would be my 4th year absent from CHS. So it's wonderful to see so many of you again, especially after COVID. And so I'm just going to talk a very brief overview about some of our reptilian work or herp work at Shawanaga First Nation that we've done over the last sort of 3 to 4 years. So here's the 3 land parcels for Shawanaga. So we're located on eastern Georgian Bay, up just north of the Parry Sound region. We have 3 different land parcels, and then the traditional territory sort of branches out from that, as well as we have here on this island, Shawanaga Island Indigenous Protected and Conserved Area, a project that we've been working on. And so I wanted to just try to also shamelessly plug that we're going to try to have a big herp bio blitz next spring. Everyone's going to be welcome to join. So I just wanted to throw that in there. But this is sort of where we're located on eastern Georgian Bay, a beautiful place on Georgian Bay, and a lot of area to work with, but sort of like a smaller, more tightly knit community within this sort of larger landscape. And sort of the whole background sort of starts, there was previous species at risk work done in the area, sort of like a decade ago. There's a couple of years of data collected here and there from staff in the community, but not really much done with that data, and sort of just fell off for a little while. But then back in 2019, I was brought on board to sort of revamp this species at risk project and sort of get it back to a state where we had sort of usable data that we could use for development and mitigation. And sort of the 2 main big projects were the T-line coming down from Hemby Inlet that was coming through the First Nation, and then the future expansion of Highway 69 into a 400 series. And so we wanted to be able to collect data on the species at risk that are in the First Nation to be able to try to mitigate any future impact of that. And just so here's a map here. Here's our main land parcel. The highway expansion, the T-line also goes through here, but this highway is going to go from a small 2-lane highway up to 4 lanes. It's going through fens, bogs, wetlands, gestation sites. And so we want to know what's there, where they're moving, and how we can mitigate that at best as possible. And so this area, to try to start a species at risk project, we have a lot of different species at risk, important animals. So I always say, this is my crew. I actually do have staff. They're really great staff, and we actually have 3 of them here with us at CHS. But sort of this is the crew. We have a huge diversity of animals, lots of species at risk, but then also lots of culturally important species as well. But we're at a herp conference, so I'm going to talk about the reptilian riches. And I work in a really important place. I'm not from Shawanaga. I have the privilege of working with Shawanaga in the community there. But we have a really high diversity of reptiles and amphibians, probably one of the highest in the province. So yeah, really lucky to work at Shawanaga. And sort of how we start a lot of our projects, this sort of really illustrates it really well. So we have sort of like the Western science, that data collection background in red. We have sort of the citizen science, or sort of that local knowledge and local help, boots on the ground. And then we have that traditional ecological knowledge, that really important knowledge that's been passed down for generations. And so when you sort of try to look at it as a whole and sort of bring it together in a project, I just have a couple of examples here. So you have like your field work, you have biking surveys, walking surveys, your mark recapture, your traditional ecological knowledge. You have those stories, those cultural roles, the inclusion of the language, and the Anishinaabe language is very descriptive. And you have stories, and then you have that sort of citizen or local science, sort of that community reporting, what they've seen over the last short while, but also going back in time. And then this sort of all meshes together. And when you combine it as a whole, you have this very strong holistic project. So when I first started in Shawanaga, a really important way to sort of work with the community is to do outreach and education. And so I'm not just doing outreach and education to the community, it's a very reciprocal relationship. I'm learning just as much as the community is learning from myself, coming from both those different backgrounds. Myself coming from a science background, and the community from that traditional knowledge background. And so we're always trying to do outreach and education. It's a very important part. Just like Sean was talking about this morning, the more you do, the more the impact is going to be there. But then we're also listening to the community, learning what the community wants, what's important to them. And so then we can direct those projects back to the importance and what's really important to the community. So talking more about the crew. So we have really committed community members. We have a lot of summer staff that are actually youth from the community. We've had really great ones over the past couple of years. And we've had the project going on for 4 years now. We have summer students. They can either sort of go into like the admin building, healing center, lands department, or like public works. And this year, pretty much every single one of them was like, we want to work with species at risk. Like we want to go catch turtles. We want to go catch snakes. All of them know that it's like really hard work. Like they know they're going to be tromping through wetlands and swamps and stuff like that. But like, we would much rather do that than sit inside or cut grass. So there's been a huge boom in the youth wanting to come out on the land, work with these animals, and have a connection to the animals, and just learn more about their own communities. Lots of them, they spent their whole childhoods growing up in the area, and now they're getting that sort of one-on-one connection with those animals, which is really important. So talking about a couple of the projects, so we don't do too much work with amphibians, but we do have some small work with chorus frogs. So I'm also just sort of going to be sort of shamelessly plugging a bit of our data and interest if anyone wants to come work with the community. But we do have some interesting chorus frog data. So we have one of the most recent records for sort of like the most northern range on eastern Georgian Bay. We have some data working with Wayne Weller, some of his historical records. We went back sort of over COVID, try to see, are these chorus frogs still present? We haven't had any success, and so we're going to try to hopefully revamp that this spring and try to do a more robust detection of those old sites, try to see, are these sites, we actually detected chorus frogs in Shawanaga 30 years ago, roughly, and we haven't heard any in our time. So they've definitely declined. And we want to try to know, why is that happening? With turtles, we've done sort of a lot of turtle work over the last 4 years. So a lot of mark recapture with this, radio telemetry, some really cool populations. We have a really cool population of coastal turtles that are actually like, they move out onto the bay during breeding season, move up into different wetlands to breed and then come back. So we're tracking some of those turtles and seeing where they're going. We have really interesting density of blandingii turtles, really high density. We have over 100 individuals caught and marked just within sort of like the main hub of the community. So it's really high density, and we really see it during nesting season. We could have like over a dozen nesters come up on sort of like a couple streets during nesting season in one evening. And then this sort of leads into turtle releases that we're doing. So part of helping to mitigate sort of the work that we're doing in the community, we're trying to make sure that the work that's happening in the community is done in a good way. Shawanaga is trying to increase the housing that we have. There's a lot of overcrowded housing, and so we're trying to develop as much housing as possible, but have a low impact. And so we're going to these sites, making sure that they're clear of turtles. Shawanaga is a natural sand deposit, and so when you start to open these sites up, it basically creates this giant artificial nesting area, which with all these blandingii turtles, they just love it. So we go in and work around these housing areas, either nest cage or incubate those eggs, and then we can actually do community releases with the community. We can do smudges and tobacco offerings while we're releasing those turtles. We've done some events in the past. There's this really sacred place called Turtle Rock. resembles a turtle. It's really cool. It points directly west out onto the bay. And so we can do community events with the community, release turtles, talk about those turtles, and then, visit those places and do those offerings. A lot of cool snake work. I think I'm running out of time here, but we have a really cool poster on some of the fox snake work. We're seeing them actually move inland farther than sort of what was thought naturally. We're getting a lot of recaptures of hognose and fox snakes over time. A lot of different work with rattlesnakes, gestation sites, sort of go forward. Some of the processing. We've been doing road surveys. So we did a couple summers of doing systematic road surveying. We got these nifty e-bikes that, they're really nice for biking and doing road surveys. But then sort of now we just sort of do it opportunistically as we're out driving. But then we also, now that the community is really involved, they're always sending us observations, sending us sightings. And so we're able to get a large number of sightings just through community involvement. And that sort of goes on to sort of creating these stewards within the community. We work with the public works a lot to make sure that we're doing things all in a good way, making sure that, let's say, grading the road isn't gonna harm turtles during their nesting season. Doing certain events. I'm just going to go an example with the rattlesnake. So in Shawanaga, rattlesnakes being the only venomous snake can be scary for certain individuals, but we've tried really hard over the last 4 years to sort of build this snake up as a very positive sort of image. And one of the ways we do that is connecting with that animal, both in hand, but then also culturally. And so there's a cultural story as the medicine protector. There's the 4 sacred berries. And that snake, if you're out collecting those 4 sacred berries, if you hear that rattle, it's to tell you you've collected enough, go back, share it with your community, and then come back another day. So we do events where we go out, we collect berries or medicines. We get to show community up close with our processing those individuals and sort of a greater appreciation for it. We actually just this summer had our first rattlesnake bite sort of in the last decade. And sort of right after that, the lady did have to go to the hospital for a couple of days. It was fairly serious. And there was some negativity towards the snakes, but it's sort of fizzled out since then. And I think without the work that has been done over the last 4 years and the appreciation that people have grown with the snake, I think it could have been a lot worse. So skip this. We've had 2 great master students over the last 2 years. We have 2 more going on right now currently, a wolf student and a bat student, no current reptile students, but this is sort of where I just wanted to like plug again, coming and working with Shawanaga to come work with us. We have a lot of great relationships with many of you already, but sort of we want to build relationships with everyone else. We want to have future master students come and work with us. And so there's not one way to do that, but sort of building a relationship over time so we can sort of continue to have these ongoing projects, ongoing data sets, long-term data, and projects that we're working on, like Kyle or Jenna's thesis. They've been really great. The community has loved them, and we get really great data for the community, but also publishable data as well. And with that, I'll take any questions.
Thank you. Thank you, Stephen. We have time for one quick question for Stephen. I have one. Who initiated the first contact with the community? Did you have someone in the community you knew beforehand, or you just threw a
yeah, so it was a connection with Emydoidea First Nation, which the project that was started there with the Liskitz lab. Shawanaga had reached out to that project, which is doing similar work, and was looking for to sort of generate a similar project. And so yeah, they had reached out to the Liskitz lab to come try to start something similar. So
thanks. Thank you.
Yeah, thanks.
All right, hi, my name's Steve Mars. I'm going to be doing a presentation here on this wildlife manual that our company Animix has developed. And so some of you guys know Carrie. She'll be picking up half the discussion, the end of the discussion, and I'll pick up the first. So just to kind of give you some background on what this manual is about. It's a fencing guide that has been in development for about 10 years. And so we've used a lot of examples from the field, engineers, scientists to basically have a better understanding of proven methods on designing and implementing roadside ecology projects with a goal to either reducing or eliminating wildlife vehicle collisions. Oh, that's good, that worked. Where Animix is part of a larger ecological consulting group. We're headquartered in London. And so I'm principally involved with most of the work that we do in the States. Carrie does most of the work that's done in Canada. So our role, basically, my role, Carrie's role, is to kind of work with wildlife professionals, with, what happened? Did the slide just change? How'd that happen? Here we go. Wildlife professionals, regulators, NGOs, you guys, some of you are here. Also, the real principal driver are the transportation authorities. I mean, it's their roads that are causing impacts to our wildlife. And I think I'll say this now and probably later on is, in spite of all the knowledge that we know about these animals, and all of the work that you guys have done to know the life history of these animals, we have bisected and segmented so much habitat in North America that it really is having an adverse effect on the future population status of many of these animals. So, you know, if we don't really start going after the transportation agencies and working with them and collaborating with them to connect habitats and to keep animals from getting run over on the roads, really, in spite of everybody having great knowledge of these animals, if we don't do that collaboration, I don't think, you know, it's a very sustainable direction for the populations of these animals. So that's kind of what we're behind, is to try and do this. Our company, we have a lot of PhD wildlife professionals that work for us. We have engineers, hydrologists, IT people. So we're committed to doing stuff that will improve, that you know, try and reduce that trajectory that we're seeing right now. So next slide. So what we did is, you can see, so we collaborate all over the planet, basically. We work in every continent, our company, except Antarctica. And did that do that again? Yeah. How is that happening?
It's just, it's some vibration.
Is it, am I hitting? I must be hitting the tables.
It's the vibration.
Okay, thank you. So anyway, we collaborate with a lot of people all over the world to develop this manual. And in the manual, I'm going to put these down for a second, really quick. We have spec sheets in here that are specific to, you know, to the species. So we have reptiles, we have snakes, we have frogs, you know, we have turtles. These and the solutions that we come up with are different for each animal and for each application. And you'll see some of the things that we talk about. So really quick, because I know we're short on time. What we've learned is most of this material, if not all of the material here, has failed over time. So you put in silt fencing lower left, you know, it gets blown over after 1 year. It's highly degrades. So there's no real UV protection in it. Our fence, we have a 15-year guarantee on it. You got here snakes getting stuck in the steel mesh. We got climbing frogs. Again, you know, lower right, we have timber rattle, I think. Lord, this is gonna bug me. So, anyway, you can see here, up here in the upper right, that's in the spring after a snow melt. So you can see like plows, they go by, they knock the fencing over. So what we've learned is hardly any of this works, if any of it does work. So we've evolved from this. We've learned from this because early on, this is really the only thing that the engineers were throwing out. And now we're pushing back and saying, you guys got to come up with different products. And so anyway, that's really the strategy behind our company is to evolve. You know, early on, we didn't have enough UV protection in our fencing material and it would break down after 3 years. Well, we've changed that. And so as we learn, we change and we come out with different products. All our products here are made in the US. It's a recycled material. So we're using milk bottles. So after you dump your milk bottle and you throw it in your recycle can, that's what we're making our fence with. So really quick, one of the things I want to talk about, back to what I was saying before, with the trajectory of species in the States, 2008, Federal Highways came out with a report to our Congress basically saying 21 federally listed species, their continued existence is being threatened by roads. So in other words, if we don't do something with those roads, those animals will go extinct. So Federal Highways right now is throwing a lot of money at DOTs to change this trajectory for those listed species, but also for other species that are under consideration for ESA. So like your Blanding's turtle, which you guys seem to have a great population, ours in the States is on a decline. And so right now, U.S. Fish and Wildlife, and that's where I came, you know, I worked with them for 25 years before retiring and coming to work for Animix this past March. We have this money that's being just injected into the DOT across the states to try and change these trajectories. So that's 7 minutes. Okay, I think I'm really close to getting to with Carrie. So yeah, so anyway, just a really quick couple projects that we're looking at. Upper left, tarantula project in southeast Colorado. We're working on right now to get tarantulas. There's a migration going on as we speak, where these males are moving across the landscape. They're moving across through these culvert pipes on national forest land. So we have a lot of partners to work on this project for tarantulas, and our goal is to try and get them into tunnels because they're really getting hammered on the several interstate roads. Lower right, we're working with Brazil with tree frogs right now is a real problem for their ability to climb. They are wicked. They are getting past our fence and they're getting run over on the road. So here's a classic example of we're able to keep aardvarks off the roads. We're able to keep turtles off the roads, but for climbing frogs, it's a real problem. But we're trying some innovation right now in Brazil where we're using skateboard tape and Velcro, the half with the little hooks. We're putting strips of that to see how tree frogs, if they can get past that. So we're trying to evolve with different species, you know, and I think it's very exciting that we have these challenges and we're working through them. So let's see here. So we talk about disadvantages of all those cloths. We'll get past that. Let's see here. This thing in the back, there's a Scan Me. We have it on our display. You can just download this. I have a few extra copies left of this. I'll get into a couple, one example in the States, and then Carrie's going to do a couple here in Canada. So bog turtle, we had a site where federally listed bog turtle was getting run over in the road along with state listed spotted turtles. We came along and we put in this crossing structure here, Animix fencing. We had a Hobbs camera with a laser on it, a trip. You can see in the upper left, a little steel pin that's sticking out that had a laser. Because, you know, as you know, camera technology really hasn't evolved. 2 minutes left. Oh, dear, I'm sorry. Why don't you go? Anyway,
We
we're-
deserve an extra minute anyway.
All right, so anyway, you can just see, we at the end of this construction, no turtles get run over. Of all the herps and reptiles that are in that habitat, all of them are using that tunnel now. So we have 14 species, every one of them is using that tunnel, nobody's getting run over on the road, and we have 12 small mammals also using that tunnel system.
Okay.
So these are really effective, you just need to, work hard with your partners to make these things go. Go ahead.
Maybe we can go into some of our question time. How many minutes do I have?
You have 14, about 4 minutes left.
Okay, perfect. That's perfect. Thank you. Thank you, Steve. Okay, Long Point. Everybody, a lot of people in Ontario know about Long Point and elsewhere. It's been going on for about 12 years. I'm going to talk about evolution of materials here. They started with a pool shade cloth at the top. We did maintenance on it this summer, and we found these holes all along the bottom at the wetland. And we were snow and ice, yeah, most likely, but we actually looked further, and it's actually muskrats causing these holes or chewing through all along the fence. So we have to adapt our materials to the site. What's there? We have to think about a lot of different things, not just snow and ice and water. Okay, here we have the mesh versus, on the left, mesh versus solid debate. What do you want? Drainage versus animals can see through it. This is the new fence called mini mesh that MTO uses at Long Point Causeway Big Creek Bridge replacement that got put in. Now we're finding that animals are sitting at the fence looking through and kind of clawing at it, trying to figure out where to go. So this, we moved to the water, it was dehydrated. So we're working with Animex through different funding sources, Priority Place Farm in Canada, Ganawini Mishkiki Fund, to look at more innovative materials that we can implement that will work for fox snakes and for our turtles. Okay, that was a metal mesh alloy that Animex has just come out with that's perforated that we're going to try different pilot studies hopefully this year. Highway 7, this started about 10 years ago, worked with David Seaburn and Animex. They supplied the materials for free to MTO to test pilot its material. Our first installation was standing on top of the ground, and it had snow damage. So we went to phase 2 where we put it below grade. We used bigger posts. There's no damage on the fence. I just saw it on the way here. However, there is washouts. The MTO is not maintaining it. We need maintenance on it, of course, but our installation method worked with the snow. Kingston, hour from here, we have 2 kilometers of Animex fencing put in. There's fencing along a wetland, not just along the road. And we have 4 crossing structures, 2 retrofits, 2 existing to the crossing structures. And we also have 12 nesting mounds. The turtles were nesting on the road previously. So we put in these massive mounds, the biggest in Ontario. It's the biggest municipal mitigation project that I know of in Ontario. So we're monitoring whether the fencing is reducing roadkill and also guiding the animals to these nesting mounds. I could do a whole presentation on Kingston and maybe next year because we're still collecting data. So we looked at using the cameras, time lapse to monitor 2 different kinds of structures next to each other. We found that it's not necessarily structural, but it's location. This is located where the turtles are moving in the water, and this one was more terrestrial, so we had more going here. This time lapse, we need better camera technology. We're working with Animex and Hobbs to get cameras that work for cold-blooded reptiles. Okay, so the predation aspect, we had 85 snapping turtles nest in our mounds. First year, we put the box cages. The skunks were going right under at the hatchling holes and going right under, making a dig. We had we caught the skunk on camera. When we added this mini mesh skirt to the box cages, the skunk could not figure out how to get in, and they are 100% effective this year with the box cages. We also looked at the chain link covers, and a lot of them were partially predated by raccoons. Different behaviors of different mammals at the nesting mounds predation. Okay, so and then this is the last one. We're adapting the Animex fence right now to for a better installation that works in water and with snow plows, massive snow on the road. Thank you. That's it.
We don't have time for questions, but I encourage you to talk to Steve and Carrie
Yeah, we have an
during the
exhibit.
breaks. Yeah.
So yes, like was said, I'm here representing the University of Ottawa. This work was done in collaboration with Atomic Energy of Canada Limited and Annie Moran. So just before we get into my research, as has been said all across this whole weekend, roads are an issue. And with roads comes many different problems. There's movement restriction, habitat loss and fragmentation, isolation, and also population decline. All of this contributes to the global biodiversity crisis we're currently experiencing. And not too far from here in Canada, we can see this as an effect on blandingii turtles because of improper mitigation against population decline due to road mortality. So improper fence maintenance and installation led to a drastic decrease in population size from around 80 to 20 just in 13 years. And here we can see some of the mitigation techniques that I'm talking about. Up here, we see a blandingii turtle on site making use of an ecopassage and over here we see a different kind of fencing that we see on site. And when these two different types of strategies are installed properly and maintained, they work in tandem to improve driver safety and reduce road mortality events. So my study species, this is the blandingii turtle that we all know and love. They're known to live up to 75 years in the wild, but despite this, they have a low reproductive success and recruitment rates, making them extremely vulnerable to extinction. They are known to have broad home ranges, and this is because though they spend a lot of their time in marshes and bogs, they perform great overland migrations of up to 8 kilometers to access necessary parts of their habitat, to find mates, nest, and also overwinter. So back in 2014-2015, Emily Hawkins, another member of the lab, performed a study to assess the main threats to this population of blandingii turtles at the Canadian Nuclear Laboratories. She was able to trap 23 individual blandingii turtles and track their movement. And she found that road mortality was extremely high in this site for the number of blandingii turtles on site. And she recommended that this be the main focus of mitigation. So due to this, AECL decided to install 7 ecopassages on site along the main access road and side road. I was able to come back after the installation and track 19 individuals, 10 of which were repeat turtles from the previous study. And my plan is to compare their movements just to see if there's been changes. So here's a picture of site. The red dot represents the nuclear power plant. And then we see a long road. This is the buffer zone, just because they're a nuclear facility. And along this road, this sees about 2,000 cars per day. So this is a lot of traffic. And so this is where the majority of ecopassages are. So I came onto site to perform some radio telemetry research. Over here, we have a photo of a transmitter. This allows me to track individual turtle movement. But first, before I can track those individuals, we have to find them. So using these nets here, I was able to sample 19 different wetlands over the course of my study. And then once a turtle was tracked, they were brought back to the lab to be processed. Various measurements were taken to assess health and age. And then a tracker was added to the back of their shell. Silicone is also seen just to ensure that the device is not torn off. At the same time, each individual is marked with a unique number. And this is how I was able to distinguish from turtles in Emily's study. Additionally, here we can see a trail cam setup. So each ecopassage has a trail cam on either side. They're pre-programmed to take a photo every 60 seconds in hopes to capture crossing events. And this is a lot of photos, so I haven't yet been able to sort through each of them, but we have had a few successful crossing event captures, such as the one I showed you on the previous slide. Additionally, I have some preliminary results and I'm excited to show you about using ArcGIS and R software. But before we get into that, just a little overview of what I found. So majority of my turtles were female. This was 13 of the 19. And then, as I told you, I sampled 19 wetlands, but only 2 of these were positive for the presence of Blanding's turtles, with the majority of my turtles, 15, being found in 1 wetland. And here we can see one of the swamps that I work in, pretty lucky. So here's a distribution map of the 2 different studies. So in black, we have my data, and in red, we have the 2015 data. This was done on R using MCPs. And as we can see quite the opposite of what we were hoping. The spatial distribution drastically decreased to my study. But I think there might be other factors at play here. So down here, we see 1 wetland, and all these points represent 1 turtle. I sampled this wetland multiple times during my study, but I only found painted and snapping turtles. In 2016, this wetland underwent a drastic drop in water level due to a down water dam breakage. And so it might be that that turtle decided to leave and find better habitat. Additionally, up at the top here, this represents the overwintering site of 3 Blanding's turtles, one of which I found in my study, and she actually overwintered in another communal overwintering site that was in that 1 lake that I told you about that has the 15 turtles. So it may be that she found that mating opportunities were not sufficient for her in that communal overwintering site, or just that that habitat was no longer hospitable. Here we see the movement patterns of 1 male in my study, both 2015 in black, and then my data in orange. So interestingly, this male tends to spend early summer and spring in the lake, and then he'll go off into an adjoining wetland to overwinter. Now, for this male, his transmitter actually broke over the winter, and due to permit issues, I did see him in May, but I wasn't able to handle him, which was kind of a bummer. So I was setting up traps along the lake throughout June to no success. So I went back in my data in 2022, and I saw that he actually made his transition into that adjoining wetland July 11th. So what did I do? I set a trap July 11th in that wetland, very close to where he was found. Lo and behold, the next day, there he was, which was quite amazing just to show his movement pattern fidelity. This was great for me also because I got to bring him back to the lab and switch out his transmitter so that I could track him for the rest of my study. And these results were quite consistent from my 2022 data to the 2015 data, just showing that these turtles show great movement pattern and site fidelity, which I think is really important just to know for future on-site activities if they're choosing to develop and things like that. And as I said, these are preliminary results, but I hope to continue analyzing my data and directly compare home ranges of individuals that were in both populations. I think it's also important to point out that road mortality has completely stopped for Blanding's turtles since the installation of these ecopassages. From 2009 to 2018, 4 adult Blandings were killed on roads, but since then, none of these events have taken place. So I think that that's a success in itself. But thank you very much. And again, thank you to Canadian Nuclear Laboratories and Atomic Energy of Canada.
Andrea, we have plenty of times for questions. Any questions for Andrea? Yep.
Yeah. On your map, are they, could you show us where the ecopassage?
Oh.
Is there a segment of ecopassage on the map you have?
No, it's just along this main road. So my turtles are actually just off the road, and they haven't actually had to use the ecopassages a lot. So yeah.
More questions? I have one. You're collecting a bunch of photographs. Are you aiming to process them yourself, or by a human, or using artificial intelligence?
Yeah, I'm hoping to use AI. The 2022, so the way I got that first photo was through human power by co-op students.
Mm-hmm.
Of course, thank them very much for their time, but that is not realistic. And so I'm hoping to find a software to be able to assess all of those photos for me.
Okay. How many cameras do you have in total?
So 14 cameras.
Okay.
It's about 5 million photos, I think.
Yeah, every 60 seconds.
Yeah, it's crazy.
Sure.
It's a lot.
Yeah. Okay. Any more questions? Oh, sorry. Yeah, go ahead.
So I just noticed you said that no landing turtles were found yet on the roads.
Yeah.
Found, or how was that assessed? Were there road surveys done?
Yeah, so they did road surveys about once a week, but also there was reports as well. So there is like at the end of the fencing, there has been some painted turtles that have gotten onto the road. So that has happened, which is very sad, but that has also decreased to my knowledge as well. So yeah.
Thank you, Andrea.
Thank
We'll move on to the next presentation.
Yeah, thank you so much, Mark. Hi, everyone. So like Mark said, my name is Kaitlyn Hall. I'm from Blazing Star Environmental. So St. Clair National Wildlife Area is an Environment and Climate Change Canada property. So we are doing this project in partnership with them. It was actually the Canadian Wildlife Service Ontario Division that contracted us to complete this 2-year project. So a little bit of background info. So St. Clair National Wildlife Area is located in southern Ontario, and it is a really important waterfowl staging area in Ontario, and it's also home to about 35 federally listed species at risk. So the National Wildlife Area actually has 2 different properties. We've got Bear Creek Unit to the north here, and then St. Clair Unit to the south. And so this map just gives you a bit more of an overview of what Bear Creek Unit looks like up close. And it's been divided into these various wetland cells. And then at St. Clair Unit, this is actually the main unit of the National Wildlife Area. CWS has their local field office here and staff accommodations. As well as something important to note is that just northwest of St. Clair Unit is actually a Ducks Unlimited Canada property called St. Luke's Marsh, and this comes into play a little bit later. So the habitat types at St. Clair National Wildlife Area, there's quite a few. There's actually 18 different ecotypes within St. Clair Unit, but the 2 predominant ones are shallow marsh and this floating leaf shallow aquatic, which is actually dominated by white water lilies. It's actually so dominated that they actually started managing it this year. It's almost impossible to canoe through it. All right, the star of the show, frag. So like many other wetland habitats in southern Ontario, St. Clair has been subject to the establishment of invasive Phragmites. So as most of us know, these grow in these really dense homogeneous stands that cause a decline in plant diversity and open water habitat, which is a problem for many species, including reptiles. So at St. Clair National Wildlife Area, the extent of frag, specifically at Bear Creek Unit, is mainly in this southwestern portion, as well as in this northeastern portion. The center here doesn't have much frag except along the dikes on the outer edge. So at Bear Creek Unit and St. Clair Unit, there are artificial dikes with pumps that help to replicate natural water levels there. And then at St. Clair Unit, the frag is kind of spread more throughout the entire unit. And both of these aerial images were taken pre-treatment in 2017 and 2018. So the Canadian Wildlife Service plans to manage all of the frag at St. Clair National Wildlife Area by 2023, so this year. So they began management last fall and they are continuing management this year. And they're doing the management through herbicide application of Habitat Aqua in the fall and then rolling the frag in the winter. So are species at risk reptiles avoiding Phragmites? So there have been a few studies in Ontario that are looking at the spatial relationship between frag and turtles. However, it's still unclear whether these reptiles are avoiding frag. And if they are, the mechanism driving this avoidance still remains unknown. Which brings us to the purpose of our study. So what is the impact of non-native Phragmites management on species at risk turtle and snake relative abundance and habitat use? So this is the overarching question or goal of our project. And in order to do this, we have to look at the relative abundance and habitat use pre-treatment. So in the spring and summer of last year, and then post-treatment, which is this season. So we are doing this through radiotelemetry and mark recapture surveys of 2 species at risk turtles at St. Clair, and then conducting VES surveys for the snakes. Which brings us to our methods. So for our visual encounter surveys, we chose 6 different defined sites at both St. Clair Unit and Bear Creek Unit. There are these 2-hectare rectangles that you can see on the map that have 50% open water habitat and 50% vegetation, which is really the kind of ideal habitat for reptiles. And so in green are our reference sites. So these do not contain any frag. It's mainly typha in these. And then in yellow are our treatment sites, which do contain frag that was planned to be managed in the fall. So for our radiotelemetry surveys, so we wanted to tag individuals, 20 individuals from 2 different species at risk turtles, and track them on a weekly basis. So in addition to radio tracking them, we also did these paired microhabitat plots, where we put a 1 by 1 meter plot centered at the turtle's location. And then another random plot located about 30 meters away. And we did that by just doing a random compass bearing using a random number generator. So at Blazing Star, we use nothing but the most advanced technology to complete our surveys. And so Maureen, who you can see in this video, one of our staff had this amazing idea to use these pool floaties in order to get across the deeper sections of the wetlands and the channels that are inaccessible via canoe, while still keeping our radiotelemetry gear dry. And this has actually worked really well for us. Besides the occasional puncture wound that we have to patch, it's been amazing. And we've had a lot of fun choosing some really fun shapes like the pineapple that Rich is lounging on in the top right there. Okay, so the results that I'm talking about today are just from pre-treatment surveys. So these are from last year. So for our visual encounter surveys, unfortunately, we did not see as much during these surveys as we hoped. So at St. Clair Unit, we actually only saw 4 individuals throughout the month that we were doing these surveys in June, and only 2 species. And then at Bear Creek, we saw a bit more. We had 4 different species and about 11 individuals. But to give you a little context, doing these surveys, it took about 4 person-hours before we actually saw one species or one individual. So it was unexpected, but we had a bit of a delay getting our fieldwork started in the spring due to a multiple variety of reasons, permitting and other things I'm sure a lot of people can relate to. So weather conditions were not great. At that time of year, the thermal difference between air and water is not much. So for turtles, for instance, it doesn't give them much advantage to bask. So they're much harder to detect. As well, the vegetation density in most of our sites was quite intense. One of our techs here is about waist deep in the wetland, trying to fight through all these cattails. So just the visibility was quite low, as well as it's actually quite noisy when you move through the typha stands and the frag. So anything that might have been there, we likely just scared it away, unfortunately. So for our mark recapture surveys, so we did these at both St. Clair unit and Bear Creek unit, and the little circles just represent each individual turtle. So despite the late start, our team did amazing, and we were actually able to capture 17 turtles that we were able to use for the radio telemetry portion of our study. So we had 8 turtles that we found at St. Clair and 9 turtles at Bear Creek. And as you can see, at St. Clair unit, we had about 6 turtles found along the boundary between St. Clair and St. Luke's Marsh, which ends up being a little bit of a problem in our next slide. So for the radio telemetry portion of our study, we had tracking 9 turtles. And then at St. Clair unit, we actually had 1 turtle lose its transmitter, unfortunately. But over the majority of the season, we had about 14 tracking events per turtle. So getting into our microhabitat plots. So what we noted here is that there was more Phragmites with the the microhabitat plots at St. Clair unit than Bear Creek unit. And the distance to frag, which much smaller at St. Clair unit versus Bear Creek unit. And if you'll recall, at Bear Creek unit, we only had frag in those 2 portions of the unit, whereas at St. Clair, it was kind of spread all throughout. So we also looked at the home ranges of each of our turtles. So at St. Clair unit, as you can see here, I'm just going to pull up the actual minimum convex polygons that we created. Those turtles caught along the boundary. A lot of them did not respect the boundary of St. Clair and decided to hop over to Ducks Unlimited's property. So Ducks Unlimited Canada was really kind and let us come over here to track these turtles. But as you can see, there wasn't much of a difference in terms of the home range sizes between turtles at St. Clair versus Bear Creek, or between males and females. However, we didn't start tracking them until end of June. So this didn't really include, prime nesting season. So it's likely their home ranges are much larger than we anticipated. And we also had a couple instances at St. Clair unit where we had turtles that we tracked way far off the property. So they're likely going out of the units and coming back in, and we couldn't represent that in our studies. So getting into the next steps, moving forward. So our team is still out there, still working hard as we continue tracking all of our turtles, conducting mark recapture and VES, now that we're in the season of post-treatment. So frag treatment started last fall, 2022. And then just recently started up again for this fall. So at the end of this field season in mid-October, we will collect all of our turtles again, take one last round of data before we sadly let them go and say goodbye. Thank you very much.
Thank you, Kaitlyn. We have time for a few questions. Any questions for Kaitlyn? Oh, yeah.
Curious then, so following the treatment, are you going to be able to go back and track to see if there's difference of habitat use of these turtles after the Phragmites has been treated?
Yeah, so they so that's what this season is all about. So frag treatment, we did all of our data collection before they started treatment last field season, and then they started last fall and into the winter. So we're now into our season of tracking these turtles now that they've managed a lot of the frag. And they are continuing to manage it this fall for any that are, they didn't get last fall, or that's, they need to go in again one more time.
And it's the same individuals?
Yeah, so originally they had only given us 6 months transmitters, and we were like, well, that's not going to do because we want to track the same turtles pre and post management. So we ended up having to catch them all again in the fall, which was quite a challenge to say the least. And then we put 12-month transmitters on them so that we could continue tracking them this season. Yeah.
One quick question, maybe, yeah.
What percentage of the Phragmites was eliminated by the treatment?
Those numbers I don't have. I'd have to get through that through CWS. I think they just based on what we were seeing coming back this year, they were able to manage quite a bit of it, but they didn't quite get it all just yet, which is why they're coming back in this fall to do like another round of management.
Thanks everyone for coming. I've really enjoyed seeing all the talks so far. Today I'm going to be talking about some work some colleagues and I have been leading to look at evaluating and looking forward on better understanding how conservation programs are affecting biodiversity and how land cover change is perhaps negatively affecting biodiversity. Before I begin, I want to start by acknowledging that where I live and where our home office is for our national headquarters that I led this work is on Treaty 1 territory and the traditional territory of the Anishinaabe, Cree, Ojibwe, Dakota, and Dene people, and the homeland of the Métis Nation. I think all of us can continue to reflect on how science and conservation has a dark history of minimizing and marginalizing the benefits that Indigenous nations have done to steward our natural resources, and how we can continue to do better. I also want to thank my co-authors and co-conspirators in this study, including some fantastic human beings. Lauren and Jim really came up with the concept of this idea before I even started at Ducks Unlimited Canada, and Paige and Llewellyn have also been instrumental in developing the ideas and concepts that I'm going to talk to you today. So we're all aware we're in a global biodiversity crisis. The recent global assessment on biodiversity and ecosystem services stated very clearly that biodiversity is declining faster now than any other time in human history. It also identified a number of direct and indirect drivers of that. And the number one direct driver are changes in land and sea use. And so in order to address this sort of elephant in the room and to halt and reverse biodiversity loss, society needs tools to better estimate how land use change affects biodiversity, to help us better design, evaluate, and then adapt conservation programs so that we have an understanding of how those programs are addressing the outcomes that we seek to see in the world. And so we're going to talk about a little piece that our team has been contributing to try to build some of these solutions. And so our approach is really based on a very simple concept that landscape simplification and habitat loss negatively affects biodiversity. As habitats disappear, so too do the species that rely on those specific habitats. And really our approach is just about estimating the shape and the nature of these relationships to better understand how the effects that our society is having is affecting species. And so we set out to build a tool to be able to predict biodiversity based on habitat. The work I'm going to talk about today is based on the Prairies Ecozone in Canada, which includes the southern portions of Alberta, Saskatchewan, and southwestern Manitoba. I'm going to be talking about results for 22 species of reptiles and amphibians that live and breed in this area, with a small asterisk on that 22 because We had to group two species together. The two tree frogs did not have enough individual records. We can separate copes and gray tree frog. And so we modeled that species together. The spatial scale of the approach we took for the output was on a quarter section piece of land, which is a 1/2 mile by 1/2 mile, or about 805 by 805 meters. The reason that we chose this is that most of Prairie Canada is divided into land parcels that are 1 mile by 1 mile. And those land parcels are further divided into quarter sections, which are the unit of land management that typically producers use to plant crops, build fences to use livestock, and that's how land is typically bought and sold. So it's a useful unit to communicate with landowners, but also as a business of how we make decisions of which land parcels to work in. The prairies are a very interesting intersection of both a biodiversity hotspot, both in total number of species and in the number of species at risk, but also a land that's incredibly important for food production, both for Canada and worldwide in terms of exports. Prairie Canada contains more than 90% of Canada's arable land and will continue to be the most important agricultural region of the country. So our approach combined 3 different types of data sources: information on species observations, so where and when species are observed, information on habitat, and then information on climate, because we know climate, especially for reptiles and amphibians, is a forcing variable that limits the edges of distributions, but also the relative habitat suitability within a species range based on climate. We built individual species distribution models for all of our study species. We did this for all terrestrial vertebrates, but I'm obviously only going to be talking about reptiles and amphibians today. So we're using the best available data that we have, which includes species observations from both publicly available data sources, such as Global Biodiversity Information Facility, but also through data sharing agreements with each of the province's conservation data centers, which tracks rare and endangered species. And so for reptiles and amphibians, we used more than 19,000 observations. And to quantify habitat data, we're using Agriculture and Agri-Food Canada's Land Use Time Series, which we chose because it's a consistent use of land classification based on IPCC recommendations. And we know that it will be available in standard time units going forward through time. And so this data exists for 2000 to 2020 in 5-year intervals. So we chose to build species distribution models with maxent or maximum entropy approach. This offered some benefits, but also some unique challenges. First, because of the nature of most of the species observations, especially for reptiles and amphibians, maxent allowed us to work with presence-only data as opposed to a structured presence-absence, structured survey data, for example, to build occupancy models. It's also typically flexible with low number of observations per species. And I'm talking relatively low numbers of observations compared to, for example, bird species where we have hundreds of thousands of observations across the study area. However, some of the unique challenges of building models where you're making inferences from maxent models include understanding and correctly controlling for important model building decisions, such as the spatial bias in the sampling process and a risk of overfitting in terms of it's very flexible in allowing nonlinear relationships, but that also means that you can get relationships that are perhaps less intuitive based on a mechanistic understanding of how these species respond. And so we included climate data, other physical predictors such as soil texture, which is an important predictor. For example, think prairie skink, hognose snake, toads that are responding to sandy soils. But our focus was on habitat data. So we included predictor variables for the habitat amount within a farm field, but also the habitat patch size. We chose to focus on the main habitat characteristics that are present in this environment, including wetlands and open water, grasslands, which we separated into native grasslands and tame grass, annual cropland, forests, and then human settlement. So think parking lots, roads, houses, farm sites. And so just to give you a high-level example of what this looks like, we're building models that are comparing presence locations of a species with a large number of background points within a defined area. We limited our sampling of background points to within a species range, and we want to use the the differences that we can try to estimate between these two distributions to better understand how habitat suitability changes with a number of habitat predictor variables. For example, what is the shape of the relationship between habitat suitability and the amount of wetlands on a farm? The output is a relative habitat suitability prediction between 0 and 1, which we can use to better understand how species are responding to habitat. So the results I'm going to present today are going to focus on looking at how the main land cover changes within this study area, which I'm going to limit to agriculture, are affecting reptile and amphibian biodiversity. So what we did was we used our species distribution models to simulate changes across a large number of landscapes of what a change from a natural landscape to a very altered agricultural landscape does and what the response is in biodiversity. So one of the main changes we were interested in was going from a natural site to a conversion to annual cropland. So we sampled a large number of sites and then simulated that landscape change on a continuous gradient as we took away larger amounts of those habitats. So we're starting with native grasslands with wetlands interspersed and a small amount of forest, and then converting more and more and more of that farm to annual cropland. The second main change in landscape that we looked at was a conversion from that same natural state, but this time to tame grass. So this is another major land use on Prairie Canada. These are lands that are used for haying or for pasture. And so these fields would be filled with typically alfalfa mixed with some exotic grasses and also some native grass species. So a different sort of agricultural land use that we predict might support a larger number of species. So the results I'm going to show you on the vertical axis are the species richness, and that's a percentage of maximum within a site as we simulate among a large number of sites. On the horizontal axis is the proportion of annual cropland, and I'm going to move from natural on the left to converted on the right. And so you can see, as expected, we get this strong negative effect of the proportion of annual cropland within a field on the number of species that we can support, both in reptiles and amphibians. And the vertical dashed line shows you, how much of your original species richness you conserve by setting aside 10% of that field as natural habitat, as either wetlands or marginal areas on the edge of the field as grassland or forest. Okay, now we're going to compare the same change, but for tame grass. And so you get this, similar pattern, but one of the main differences, if we look on the far right edge of the grass, is that far right edge of the graph is that the decline happens later on the conversion of land compared to an annual cropland. Okay, so the amount of tame grass still had a negative effect on biodiversity, but the decline was not as sharp as the conversion from annual cropland. So I want to end by just presenting one more small set of results to look at the value of conserving small amounts of natural habitat within these agricultural fields. And so conservation projects in this landscape is often small because it's all held in private land. And so we work with landowners to conserve small amounts of habitat within their fields. So what I did was use our species distribution models and compared the species richness on places where we've delivered conservation easements. So we've paid a landowner to conserve the wetlands or grasslands within their farm field compared to random sites nearby that are on unprotected land. Okay, and we see here I have the predicted species richness on the vertical axis, easements on the left that are protected, no protection on the right, and the paired lines are drawing the sites in the same region, so the species pools are similar. And so I wanted to display the raw data so that you get the picture that this is messy because the amount of natural habitat is different and the landscape context matters, but there is an overall higher predicted species richness on those spots where we're delivering easements compared to areas that have no protection. And so the three main take-home messages I want you to get from this talk: one, annual cropland is a major contributor of biodiversity loss. That's not a new insight, but it helps to have the numerical estimate of how strong that decline is. The next is that not all agricultural practices are equal. Tame grass fields seem to support a higher amount of biodiversity than annual crop fields. That's true for reptiles and amphibians, but also for birds and mammals. And that both through that simulation and through the comparison of easements, it provides support for these projects that conserve remnant patches within working agricultural lands. So thank you very much for coming, and I'll take time for a quick question.
Thank you. Thank you, James. We have time for a couple of questions. Yeah, Sean.
So one of the challenges with both the reptiles and amphibians is that this is a generally small species pool. And so like the wiggles you saw in some places, I would not overinterpret that, because many of the places we're sampling, I wanted to get a range in climate and species pool, but some of these places only have a community of 3 or 4 amphibians or 3 or 4 reptiles. And so the overall negative response was strong. The wiggles, I wouldn't interpret that as a mechanistic effect. Yeah, good question.
One more question. Yeah.
Yes.
Is there any, or are you doing some work on the side looking at connectivity or proximity to other patches and how that?
Yeah, really good question. So I'll very quickly say that we had variables that were within the field, and even though we were predicting within field, we had variables that went in for local amounts of habitat and a larger spatial scale, because we know many of the species are not just going to respond to on-field amount of wetlands, it's a broader landscape. So we had both local and neighborhood effects, and the neighborhood did matter.
Thank you again,
Thank you.
James.